Hello everyone, last time we already introduced the operation method of MLPA-NGS technology. Next, I will take the results of Y chromosome microdeletion as an example. To introduce the usage method of MLPA-NGS analyzer. First, log into our official website. Click on the Download Center and download the MLPA-NGS analyzer software. Double-click to open the software. Register an account and password. After completing the registration, close the page. Double-click to open the software and enter the login page to log in. Click to enter the main program. After entering the main program, you can see three options: FastQ Analysis, CNV Analysis, and Help. The default interface is the FastQ Analysis. First, users import FastQ sequencing files for analysis via the FastQ Analysis button. The analysis is completed, and result files will be exported. One is an MLN file, and the other is an Excel file. MLN files are for machine reading, that is, for further analysis by the CNV analysis module. Excel files are mainly for human reading. Multiple FastQ files can be input for each analysis, and a MLN file and an Excel file will be generated. Kit. Users should select the corresponding kit for analysis, based on the kit they used for testing. Sequencing folder path. Here, users select the folder where the FastQ files to be analyzed are located. File name signature. After entering words or phrases in the text box and clicking search, the system will only search for files whose names contain these words or phrases. Project file save path. Project files refer to MLN files and Excel files. The default save path is the same as the sequencing folder path. If a new path is selected, it will be saved to the corresponding path. Project file name. The default project file name is the kit name plus the time when the analysis is completed, the suffix MLN, or the XLSX of the Excel file. If a new file name is entered, it will be saved with that name plus the suffix. We have chosen the YCMD results for interpretation this time. Click on the sequencing folder path to select the FastQ file that needs to be analyzed. For our samples, the outsourcing sequencing service we chose is bidirectional sequencing. Each sample will return to sequencing files, one for the forward direction and one for the reverse direction, labeled R1 and R2 respectively. Our software can only analyze R1 files and cannot analyze R2 files. Enter R1 in the file name signature to filter files whose names contain R1. In the lower left corner, users can select the sample that needs to be analyzed. Can select all. The selected samples can be cleared, or clear the selected samples with one click. You can also select several samples individually. After selecting the samples we need to analyze, the save location, and the name, we can start running it. The running time depends on the size and number of FASTQ files, as well as the user's computer configuration. During the running process, the progress of the operation can be displayed here. Users can roughly estimate the running time based on the progress here. After the operation is completed, we can obtain machine-readable MLN files and human-readable Excel files. Click on CNV Analysis to enter the Project File Analysis interface. Project Path. Users can select the MLN file to be analyzed here. After selection, click Open Project, and the interface will display the relevant chromosome information after each file name. You can also close the current project data and open another project data. The file names displayed in the left list are the sample numbers at the time of submission. Click the Display button on the right. The sample of the selected radio button here will be displayed on the right side. A, X, Y represent autosome, X chromosome, Y chromosome respectively. Green represents qualified, red represents data abnormality, and brown represents the critical zone. The ratio of Y to X represents the dosage ratio of the Y chromosome to the X chromosome. Blue represents a ratio around 1, which is judged as male. Pink represents that the ratio is around 0, which is judged as female. Brown represents the critical section. Detection of Y chromosome microdeletions, such as analyzing the copy number variation of a sample, requires at least one normal male sample as a control. In the drawing mode at the top right, you can select either a CNV chart or a reads chart. After selecting the sample and control, click Display to show the copy number information of each locus in the sample relative to the control sample. If there are no male samples or all male samples are unqualified, the control samples cannot be checked, and the analysis of copy number variations cannot be performed. At this point, you can choose the reads graph for analysis to display the reads information of each locus in the sample. Experienced analysts can determine whether there is a Y chromosome microdeletion in a sample based on the sample's reads information. Here is the name of the kit. The second line is the file name of the sample. The third line contains the numbers of the control samples used. The fourth line is the name of the MLN file. Here are the test results for the 16 SNP in this sample. The numbers 1, 2, and 3 below represent the three types of SNPs: wild type, heterozygous type, and homozygous mutant type. If it is green, it indicates that the SNP detection is qualified. The 12 5-pointed stars above represent 12 putative SNP, detected by the SNP detection method, which is for SNP quality control. SNP signature is the merging of 16 SNP into 8 numbers. These 16 representative SNP of each person are generally not completely the same, and can be regarded as the characteristic code of the person's genetic material, which is convenient for distinguishing samples. There are Show Previous File and Show Next File buttons at the bottom of the interface. These two buttons allow for quick switching between the samples that need to be viewed. The Save the Figure button can save the bar chart on the current page. The Configure Subplots button can adjust the shape and size of the current page. The Zoom to Rectangle X or Y Fixes Axis button can zoom in on local information. The left button pans, right button zooms X or Y fixes axis, Control fixes aspect button can perform the shortcut operations of panning with the left mouse button and zooming with the right mouse button on the page. You can also use the left and right arrows below to back to previous view or forward to next view. Clicking this button can reset original view. The function of Save Image below is similar to the Save the Figure above. The Move horizontally on the right side is to facilitate users to move the interface after zooming in left and right. Zoom horizontally refers to scaling in the horizontal direction. When the probes are dense, it is convenient for users to analyze the probes. If users want to learn more about the Y chromosome deletion sites, they can select CNV chart CHR in the drawing mode. After magnification, the precise location of the probe site on the Y chromosome can be observed. Click on Reads Data or CNV Data in the drawing mode to get specific data for each locus. A better way to check the number of reads is to browse the Excel file obtained from data analysis. The CNV data will change as the selected control sample changes. Next, we will interpret the results of each sample. The sample number during interpretation is the name of the sample file during sequencing. Samples 3 to 11 are normal male. As we can see, these samples have only one copy of the X chromosome and one copy of the Y chromosome, which is consistent with the XY chromosome karyotype of males. In normal male samples, not every probe is normal. We often see that in the AZFC region, specifically this area, individual probes can be very high, or individual probes disappear. These are all normal phenomena, and are due to the polymorphism of certain regions of the Y chromosome. Samples 1 and 2 are normal female samples. As we can see, both the X chromosomes and autosomes in the female samples are diploid, while there is basically no signal on the Y chromosome. In the AZFC region, if there are many missing probes, such as the typical deletion from Y95 to Y106, it is considered an AZFC deletion. Sample 12 and Sample 14 both have these characteristics, so it is determined that they have AZFC region deletion. The sample 15 is a deletion in the AZFB and AZFC regions, with the typical feature of deletions of probes from Y64 to Y109. Sample 13 has deletions of A, Z, F, A, B, and C, which is the most severe type among cases of Y chromosome microdeletions. A typical sample with deletions of A, Z, F, A, B, and C shows a deletion from probe Y20 to Y109. retaining only the SRY gene on the Y chromosome in a nearby region. Since sample 13 has the SRY gene, it exhibits male characteristics. However, its relative copy number of the X chromosome is 2, and it is generally diagnosed as 46, XX sex development disorder. All the above positive samples have been verified using other quantitative PCR kits. Our kit is more intuitive than quantitative PCR, and can determine the copy number of chromosomes. For example, sample 15 not only has a deletion of the Y chromosome, but also, the part that is not deleted is diploid. It is difficult to clearly identify such characteristics using quantitative PCR. The above is the complete interpretation process of the Y chromosome microdeletion test results. Thank you all for watching. If you have any questions, please feel free to contact us at any time.